the integral from -2 to 5 of x squared times quantity x minus 5 dx. Right now you're probably saying, please tell me there's a product rule like there was in differentiation. And the answer is, sadly, no. No product rule. The best thing to do here is just multiply on through and duke it out. So here we go. Let's put on our boxing gloves and let's get some math done. Let's take the integral from -2 to 5. We'll distribute the x squared to both the x and the -5, yielding x cubed minus 5x squared. And that's all dx. Notice how I keep the parentheses around the entire integrand. This is extremely important. Now, we have a property of integrals that says if we add or subtract in the integrand, we can just add or subtract the integral, which is pretty neat. So this is equal to the integral from -2 to 5 of x cubed dx minus the integral from -2 to 5 of 5x squared dx. Now we have constant rule. We can take this 5 out from my second integral. This is equal to the integral from -2 to 5 of x cubed dx minus 5 times the integral from -2 to 5 of x squared dx. And now we can actually take the integral, remembering the second property of the fundamental theorem of the calculus, which says the first thing you do is you find the antiderivative. Well, the antiderivative of x cubed, we add 1 to the exponent and divide by that number, so we have 1 over 4 x to the 4th. And this is from -2 to 5 minus 5 times the antiderivative of x squared. Again, we add 1 to the exponent and divide by that number, so we have 1/3 x cubed, and this is from -2 to 5 once again. Now, we have 1/4, and I like to pull that 1/4 out of the entire thing. We can use constant rule a little bit right here too. Times, we plug in our b, so we have 5 to the 4th, minus, now we plug in our a, -2 to the 4th, minus 5. We can also pull out that 1/3 as well from here, so we have minus 5/3 times, we'll plug in our b, so we have 5 cubed minus, and we'll plug in our a now, -2 cubed. Alright, let's do some further math here. We know that 5 to the 4th minus -2 to the 4th is 609. Well, we don't know that, but you can figure it out with a calculator. And we also can figure out that 5 cubed minus -2 cubed is 133. 1/4 of 609 is 152.25, and 5/3 times 133 is 221.667 approximately. And so the total answer is -69.417. And that is some hardcore integration. Yeah. If you're in calculus right now and your teacher's giving you trigonometry and integrals and you can only do it by hand, you should thank the stars above you, because doing trig is so easy. All you gotta do is just know the formulas for the antiderivatives, or to know the formulas for your derivatives, and then just work backwards. Either way, doesn't matter. Whenever given trig by hand, you'll usually be using your formulas. Like, for example, we've got the integral from pi over 4 to pi of secant squared theta d theta. Now I gotta find a function that when you take the derivative of it, you get secant squared theta, or in other words, the antiderivative of secant squared theta. Turns out it's tan theta, because the derivative of tan theta is secant squared theta. Pure memorization. And we'll plug in our b, the pi, then we'll do subtraction, we'll plug in the pi over 4, and that's by the fundamental theorem of the calculus, part 2. So let's do that right now. We've got tangent of pi minus tangent of pi over 4. And because tangent sine over cosine, we've got sine pi over cosine pi. Sine of pi is 0, cosine of pi is -1. 0 over -1 gives us 0, minus tangent of pi over 4 is 1, because sine of pi over 4 is root 2 over 2, and cosine of pi over 4 is root 2 over 2, and root 2 over 2 over root 2 over 2 is 1. So 0 minus 1 is equal to -1. And that is the answer for this particular problem. I'll do one more. Once again, we'll just use our trigonometric formulas from derivatives. Here we've got the integral from pi over 4 to pi over 2 of cosecant squared t dt. Now we got to find the antiderivative of cosecant squared. Well, I know that if you take the derivative d over dt of cotangent t, this is equal to negative cosecant squared t. Now I don't have a negative here. However, if I put a negative in front of the cotangent t, things might work out. Let's try. The derivative of negative cotangent t is equal to negative cosecant squared t, which is positive cosecant squared t. So the antiderivative of cosecant squared t is indeed negative cotangent t. So we've got negative cotangent t from pi over 4 to pi over 2. Now whenever I plug in my b and my a using the fundamental theorem of the calculus, part 2, I don't like having constants in front of my function, so I'm going to take that constant out just to make everything a little bit easier in terms of arithmetic. So let's plug in that pi over 2. We've got cotangent of pi over 2 minus cotangent of pi over 4. Now let's figure out what cotangent of pi over 2 is. We've got negative in front. Cotangent is cosine over sine. Cosine of pi over 2 over sine of pi over 2, or cosine of pi over 2 is 0, and 0 over anything is 0, so this is just 0, minus cotangent of pi over 4, well that's, again, root 2 over 2 over root 2 over 2, and that's 1. So the answer is -1, which is positive 1. Trig, very easy with integrals by hand. Just memorize your formulas and you'll be fine. Let's take the integral of some exponential function. Here we've got 1/3 the integral from 0 to 3 of e to the x over 3 dx. Well, we want to find the antiderivative of e to the x over 3. So let's play around a little bit. We know that the derivative of e to the x is e to the x. But here we don't have e to the x, we have e to the stuff. So let's try taking the derivative of e to the stuff, and let's see if we can come up with something that looks like e to the x over 3. So we got the derivative of e to the x over 3, and by the way, x over 3 is the same thing as 1/3 x. So the derivative of e to the stuff is e to the stuff times the derivative of the stuff, and the derivative of x over 3 is just 1/3. So the derivative of e to the x over 3 is 1/3 e to the x over 3. What this means is that the antiderivative of 1/3 e to the x over 3 is e to the x over 3. Well, do I have a 1/3 e to the Yes. Yes, I do. Take a look at this 1/3 in front. Constant rule allows you to take a constant out of the integrand, but it also allows you to put a constant inside of the integrand if it's being multiplied. So we actually have a 1/3 e to the x over 3. And what we just found is that the antiderivative of 1/3 e to the x over 3 is e to the x over 3. We found our antiderivative. I'm going to rewrite this integral as the integral from 0 to 3 of 1/3 e to the x over 3 dx. Now remember that an antiderivative, when you take the derivative of the antiderivative, you get the function itself. We wanted to find the antiderivative of e to the x over 3. But instead, we ended up finding, by pure chance, the antiderivative of 1/3 e to the x over 3, which suits us just fine because there's still a 1/3 in there. And the antiderivative of 1/3 e to the x over 3, as we noted, is e to the x over 3. So this is equal to e to the x over 3 from 0 to 3. Well, let's plug in our 3. We've got e to the 3 over 3 is e to the 1, minus e to the 0 over 3 is e to the 0. E to the 1 is e to the 0 is 1. And the answer is e minus 1. When you have exponential functions, a lot of times you're going to have an e in your answer in some form or another.